It is said that only the truth endures, and the gold bars being forged here today are one of the few things that will have a value 1,000 years from now. Whilst everything else decays, gold doesn't. The story of gold is the story of our modern world. For millennia, gold has fueled the exploration of new lands, won wars, driven technological discoveries, inspired beauty, and played a major role in the rise of global trade. And this is why gold is a universal symbol of value. This is the story of Otjikoto Gold Mine in north-central Namibia. And this film tells the remarkable journey of where our gold comes from, how it is mined, and why it continues to have such extraordinary value, not just for shareholders across the globe, but for all Namibians. Today, Otjikoto gold is used in minute quantities throughout the modern world. In the cameras, computers, and televisions that record and edit these images. In the cell phones, cars, and buses that bring us all together. These are the golden moments that really matter in our lives. Gold is not only useful, it is supremely beautiful. And the allure of gold is legendary because it tricks the senses. How can something so small be so heavy? How can something so small be worth so much? Gold is also incredibly rare. It is estimated that all the gold mined in all of human history would form a single cube, just 20 meters or 66 feet on each side. That's about the size of a tennis court 10 meters deep in gold. And it is that scarcity that makes gold so valuable. It is a miracle to think it took an exploding star to create something as unique, valuable, and enduring as gold. Gold is rare on Earth because it is rare in the universe.
How does gold get here? So if I look at my wedding ring and the gold in my wedding ring, it's amazing to think it actually came from an event that happened 6 billion years ago, before the Earth was here. There was a star, it was a very, very heavy star, and it was a very, very heavy star that was so heavy that it collapsed under its own gravity. And when that happened, it produced the rarest type of explosion in the universe, which is a supernova explosion. But then immense energy blows these elements to the winds and spreads them out around the cosmos. And then later they can come together to form rocky planets like ours. That's where the heavy elements come from. And then geology takes over, concentrates them, brings them to the surface, puts them in certain rock strata, and then at some point a discovery leads to an ore that's rich enough to develop. It's rich enough and gold is rare enough that it makes sense to move hundreds of tons of rock every day and extract the gold that's part of my wedding ring and jewelry and gold bars and all these things. It's a story that begins 6 billion years ago and it finishes here at the home of B2Gold.
Ndawe is the hands of the mine. It is her job to find out where the gold is. She has to make sure she gets the right gold ore in the right quantities, and then get it out of the pit as quickly and efficiently as possible. As the mine geologist, Ndawe knows her rocks.
I have what we call specimen, rock specimen, which has some veining, some sulfide veining. We've got some calcite here, some pyrrhotite in here, and this could possibly have some gold grades, which is invisible to the naked eye. I had a professor who would actually lick the rocks before he does anything. Find a good piece for you. You can tell a million stories of what happened here, how the mineralization is sitting, how the garnet grains are just forming at the edge of the vein. You can't see the naked eye, but it's like it has gold in it.
To understand how gold came to be at the Otjikoto mine, we have to go back nearly 900 million years, when the Earth was made up of one large supercontinent, surrounded by a shallow sea, and when modern-day Namibia sat between the Congo and Kalahari landmasses, in what has become known as the Damara Belt. Deep inside the Earth, the semi-molten rock mantle starts upwelling, causing tension at the Earth's crust. The land starts to split and slip, and a rift valley system is born. Over the next 100 million years, ocean sediments build up in layers. New upwelling from the hot mantle creates a new rift valley system to the south. The two oceans join to form the 1,000-kilometer wide Ocho Sea. This ocean crust is the bedrock we mine today. Continental sea spreading stops. Now everything goes into reverse. Where these two plates collide, a vast mountain range forms. Mantle plumes, like floating balloons, push their way through the sediments above. As the superheated granite is pushed up and injected into the sedimentary layers of rock, it becomes a geological battle zone. At 500 degrees Celsius and 6,000 times the pressure of the Earth's surface, gold is dissolved in sodium, sulfur, and iron-rich fluids and propelled towards the surface to create rich veins of mineralized rock that we mine today. Heat and energy from deep below the Earth's surface dies down. Cooling occurs, and mountain building stops. Over the next 500 million years, the power of the wind and the rain breaks down the overlying rocks, washing an estimated 1 kilometer of the Earth's surface into the ocean. All that remains are the exposed gold-rich veins that we are now able to mine in north-central Namibia at Otjikoto Mine. To see where the gold-rich veins are located today, Ndawe uses a three-dimensional computer model.
So what I'm looking at it now is on plan, whereby the hot colors represent the high-grade areas and the cooler colors represent low-grade to medium ore. These models are generally used by the grade control section to do their planning, in our case our drill planning, and also the mine planners use the block models to create the designs of the shells. And for me just to know where the ore is. So it's mainly used by the grade control and the mine planners.
The 3D model is used to locate exactly where the gold-rich veins are, from above and deep below the ground. The gold-rich veins, here shown in red, average about 30 centimeters in width and continue for more than 700 meters below the surface. Today, the pit is nearly 1.5 kilometers long, 580 meters wide and 70 meters deep. Mining will most likely go underground by constructing mine shafts following the same gold veins as they go. Located to the north, here in yellow, and running directly below the Otjikoto open pit, B2 discovered another, smaller but richer gold deposit. Mining of both gold deposits will continue, and the total possible gold yield from the two pits is approximately 1.8 million ounces. That's 2.9 cubic meters of gold, weighing 56 tons, worth $2.2 billion. Otjikoto is considered a low-grade gold mine because it takes 1 ton of rock to produce just 1.5 grams of gold. That's 1 pickup full of ore to get 1 memory card of gold. Because gold occurs as very small grains, the easiest way to see it is to look under a microscope.
Okay, what I'm going to show you now is a sample depicting some coarse gold This is actually a very small sample. This is magnified about 40 times for us to see this coarse gold grain. It's really tiny, it's less than a millimeter in size. As we see here, it's hosted in the country rock, our hornfels, and the indicator minerals like garnet there. And then here we've got our coarse gold grain. It's really pretty and really, really tiny. And most individuals think that you can actually pick up gold in the mine and you wear it. But actually this is really small, it's less than a millimeter in size. And this is what we call our coarse grained ore, and we also find some fine gold in the pit.
Using the 3D model, Ndawe directs the reverse circulation, or RC drilling team, to where the gold is likely to be.
Looking at these chips, as I can see, there is pyrite, pyrotites, and magnetite. So the possibility that there should be gold, it's very high. There is no way I can have this combination of minerals and there is nothing. There should be visible gold.
The drill rig takes 2 rock samples every 2 meters. Both must be representative of the rock ore being drilled, and both must be identical. One goes to the lab for analysis, and one is analysed on site by Michelle to provide Ndawe with an immediate idea of what ore she has available to extract for the processing plant.
So if I have a lot of chips like this, I'm very happy.
Everything on the mine is about feeding the plant a consistent and continuous supply of the right blend of gold ore.
The process goes on just the same way.
Michelle's on-site analysis provides Ndawe with an immediate idea of how much gold there is. Ndawe arranges to drop off the rock samples to Philippe at the on-site laboratory for further analysis.
How may I help you?
I've got a batch of urgent samples to send through to you. Can I send them?
We can give you a result by end of the day or tomorrow first thing in the morning.
See you soon. Bye. So you think I can have them as soon as possible?
Yes. Sign here.
Philippe is the eyes of the mine. It is his job to tell everyone else exactly how much gold is in each rock sample.
As possible. 3 hours. Okay. Thanks, Philip. Bye.
At the laboratory, there is a mechanical process to first crush the rock sample to a fine flour that is then smelted at more than 1,000 degrees centigrade.
So we melt the sample together with the fluxes, and now the denser materials which contain gold, lead and silver will be at the bottom. This method simply is like mixing oil and water. You can mix it and they will mix very well. Because of the difference in density, water will settle and oil will come on top. It's the same what is happening here. Because the slag is less denser than the metals are going to settle at the bottom and the slags will be on top. And what we do, just to remove the slags, and we remain with our metals.
Hello, Philip.
Hi, Ndawe. We managed to finish our results on time.
How's it looking?
It's like we have high grade here and the repeats are repeatable.
Send them through to me then, please.
All right, thank you, Ndawe.
All right, bye.
Bye.
Ndawe now knows she has the right ore for the processing plant. To get at the gold, you first have to blast it.
Pamba, come in. Attention, everybody. Please do not use the mining channel. It's blasting time. Now he's about to count down. The detonator is making sure the connection is right. Very clear.
Okay, Kitana. Countdown of 5 by the way. Starting now. 5, 4, 3, 2, 1, fire.
After each blast, Ndawe uses a clever piece of gadgetry called blast movement monitoring to find out exactly where the rock has moved to.
If, for example, I'd planned ore in this particular area, but the blast has moved the material to the eastern side, then of course the ore has also moved to the eastern side. So it doesn't help me mining where I planned it, whilst knowing for sure that actually it is moved. So I need to target the actual movement of the ore. So this gives us valuable information in terms of where our ore is sitting post-blast. The chip in here is telling us where it is. It's sending a message to us. It's saying, find me, find me, find me. And it's got a battery life of 12 hours once we've activated it. So if I don't find it within the next 12 hours, then it's gone, it's lost. Not bad, well done. That's very good, very, very good. For the deeper ones to find it this quickly, he's done well.
Because Ndawe knows exactly where each ball has moved to, her team can then survey and map the movement of the ore body after each blast.
You can't quantify really the value of this. I can't even put money on it.
Now it's time to get the ore out of the pit as quickly as possible and into the rock crusher. Andreas's job is to turn rock into gold. Because the plant is always hungry, consistency is the key to success. Andreas and his team need consistent and reliable ore to feed the plant.
My job is to extract as much gold as we can from the ore. So Ndawe brings our ore from the pit into the crusher. As soon as it falls into the crusher, that's my job. So the crusher crushes the rock from 25 centimeters to about 15 centimeters. The rock is then conveyed onto the coarse ore stockpile. From the stockpile, the ore is conveyed by the conveyor into the mills. Now what we want to do in the mill is we want to break down the rock size from about 15 centimeters to about 1.1 centimeters. That's a fingernail in size. Inside the mills, we have these steel balls. Now there's hundreds of these steel balls inside the mills. As it turns, it crushes the rock from 15 centimeters to about 1.1 centimeter. From the mill, the rock is crushed to almost sand. It's mixed with water to give you a slurry. Now the cyclone cluster that you see here separates the coarse sand from the fine sand. The coarse gold is extracted via the gravity circuit, which is more of a mechanical system. And the fine gold is extracted via the leach circuit, which is more of a chemical process. Now currently we extract about 70% of our gold from the gravity circuit, and we extract the other 30% from our leach circuit. In total, we recover about 99% of our gold. And we know this because we do check, and that's our job, to make sure that we throw away as little gold as possible.
This is our control room. This is the eyes and ears of the plant. This is where we monitor the whole operation, from crushing all the way to the gold room. This is Monet. This is our plant control room operator. He's the one that's busy monitoring our systems and making sure that all our systems are working as they should be. This is really good. This is great stuff. Cyanide controls are spot on. This is very good. This is what we want.
Now, one of the interesting things about gold is that gold doesn't react with many things on Earth. But what we do know is that gold dissolves in cyanide. Gold loves cyanide. So in our process, we dissolve the gold into cyanide. And now to get the gold out of the cyanide solution, we use this coconut carbon. Now the gold gets attracted to the coconut, it goes onto the coconut carbon, and then we elute it. After we elute the gold out of the coconut carbon, we then have a solution that's concentrated with gold. We call that pregnant solution. Now this pregnant solution is what we send to the gold room. Now it's Colin's job to make sure that we get all the gold out of that pregnant solution and make gold bars.
So we are ready for pouring. This is what we call our yellow bread. Well, that is what we call our pour. This is not just an ordinary yellow bread. There goes our beautiful bars, cooling it down. I'm happy. We've got nice bars. A lot of people have contributed to this bullion. Starting from exploration, the mining people, the truck drivers, people doing all the blasting, the people in administration, people from the warehouses, processing plant, mining, and we from the gold room. We've all contributed to this bullion. And this is a Oshikoto B2Gold Namibian bullion out of the Namibian soil. We cannot eat this, but we are making a living out of this bullion that we are holding in our hands from B2Gold.
The Ochikoto mine is a 3 shifts a day, 24/7, 365 days a year operation, non-stop for years to come. The big wheel keeps turning. Through their open management style, the Ochikoto mine has created a world-class team.
We're unusual in the lack of expats we have working in our mines. It's typically 97-98% of the workers are from the country, and our goal is ultimately 100%.
There was people that said you'll never find workers in Namibia. We found those workers. Now we've taken a lot of those workers to Mali. They're now the trainers. Right, so they're now an expat working in Mali. They have to pass on the B2 legacy. We do things in such a way that we empower the local population to take responsibility at the end of the day to make it theirs.
And that is simply because of the style of management, which is open, and it empowers people. They're doing it with passion, and that is satisfying. You can really see that these guys are engaged. They have started adding value with commitment. The results have spoken for itself. We have always managed to deliver on our production targets, and we have also set up a sound working environment with labor relations. This just manifests in the caliber of the teamwork that we have set up.
The real value of the Ochikoto gold is measured not by how much you have, but what you do with it. As the experienced B2 team know, mining and conservation have to work hand in hand.
So Namibia is a very special experience, and it embodies all the things we're trying to do. The mining industry historically was very secretive, very arrogant, not necessarily respectful of the environment or the people in the places they worked. In fact, sometimes very disrespectful. Before you can deliver the shareholders, you have to deliver to the countries you go and to the promises you make to the leaders and the people of the country. One of the key reasons for the success of B2Gold is delivering on those promises, and that's respect and fairness and transparency. And this is a very special place. To be able to work in harmony with the environment and a mine, I think it's a first, and I think this is a game changer for mining.
Here at B2Gold, we do our part by recycling as much water as we possibly can. The tailings from the processing plant is pumped here to the tailings dam, which is fully lined to make sure that there is no seepage of any of our harmful chemicals into the groundwater. The future of power supply at B2Gold is very bright. B2Gold is likely to install a solar plant to harness Namibia's abundant solar radiation. This could be the future of industry in Namibia, a country with one of the highest solar radiation rates in the world.
The Ochikoto mine is located on 20,000 hectares of farmland in the heart of Namibia. Whilst 2,000 hectares is used for mining, the rest is being managed as a game reserve, home to a wide range of African wildlife, including rare and endangered species.
I want to walk away from this knowing that I was part of an organization or team that had made impact and that had mined responsibly. And that's my passion about B2Gold.
Giving back has to be part of your belief system. You can't just take. It's really important that whatever you do in life, in my opinion, is done with a sense of balance, a sense of morality and ethics. And we're living in a part of the world that is developing. We should never forget that Africa is on the rise. And so if we're going to operate within this continent, I think we must do so with compassion, with a social conscience. You've got to always give back, and what you give comes back manifold.
We're ahead of the curve, and examples like this in Namibia, Otjikoto, and the whole thing we've done are just going to continue to show people this is the right way, and it will change. It's inevitable in my mind, because you won't be able to get away with it anymore, and it can be done, and this is an example.
Let's make an example and create what I love, a world-class game reserve. That's what we're aiming for. And to give something back, to the communities, to the country, nationally, internationally, show people what can be done.
We're showing that a responsible mining company can really add value to the environment. And the actual mining operation itself is a pretty small part of the environment.
Part of the Otjikoto mine's investment in the future is to demonstrate how mining and conservation can live side by side. This is a time of change and transformation. It's all about showing the interconnectedness of things. Working in harmony is part of the strategy.
From the outset, we always said at B2Gold what we want to do is show that a responsibly mined area and well-run operation is a clear net benefit to the surrounding natural environment. And that's what we've done, setting up the Education and Environmental Research Center. We're doing that tangibly. People can come here and see what the value is that we're adding.
Once we're gone, we leave something behind that is sustainable. It supports the communities, it educates the people, and it makes them just realize that you've got to look after the earth. This is a gift that we've been given to hand on to all future generations. It's our legacy. And that's my dream for this place.
The Otjikoto mine has become a center of excellence, a living laboratory combining education and scientific research with conservation. Colorado State University's Little Shop of Physics brought to Namibia their passion for making science something you can learn in your own backyard.
When we developed this education center here, what is really fundamental to physics is to explain to the world that science is not as complicated as one might think, that science is all around us and it's very hands-on.
Namibian students learned about the natural wonders of the game farm and how the world of physics works. Namibian teachers also did training in the Little Shop of Physics and were given a box of physics equipment to take back to their own schools.
Wow, it was fantastic. It was so cool.
The thermal camera.
Sky rocket.
Launching a rocket. Light can change the colors.
The high-speed camera. Those are one of the things that I'll never forget.
Things that we do in our everyday life, but we didn't know that they are connected to science.
How to create a very simple rocket.
That's something we can do at home, with things you can just get around the house.
This is really beneficial to us teachers who are teaching physical science.
Through fun, you get to learn
innovative ideas that will empower my mind as well, which I can take back to my children. When you have all the materials that you need, everything is possible.
Even in the exam, they will try to remember because they've done that.
I'm going to take the experience I've learned here, and then I will try to create more content that is local.
For me, I believe science moves the world. Without science, we will not understand the world around us.
Now we know where our gold comes from and how it is being reinvested into Namibia's future. Just as it has for millennia, our gold is used for trade, wealth, and beauty. More than 50% of all B2Gold goes into jewelry.
Gold looks like nothing else on earth.
Because gold has no equal. Pure gold.
Pure Namibian.
Say you're Namibian. Chokai, Uyakai, Takwano, Monohomonati Fela. Uyakai, Uchakai, Takwano, Monohomonati Fela. Ayo, Papa. Yeah, 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 yeah. Meshiwa, Meshiwa, Kalahare. Meshiwa, Meshiwa, Mami Dese. Meshiwa, Meshiwa, Kalahare. Meshiwa, Meshiwa, Mami Dese. This land of wide open spaces, so many, many, many faces. This land of wide open spaces, so many beautiful faces. Namibia.